So hello everyone. As Ashley said, we're going to be talking about a remote WebDriver, basically going from the basics of what WebDriver is, and then talking about the JSON wire protocol capabilities and all the internals of what is actually going on when you run a test remotely. My name is Santiago Suarez Ordoñez. You can find me here, SantiYCR at Twitter, and I also work for Sauce. I wanted to make a link for the presentation, so I think if you hit this URL, if you guys want to have it locally, it should open the slides. Otherwise, I'll just post it via Twitter, so just find me on Twitter and I'll post a link later. So here's the agenda. Actually, no, let me stand up. Here's the agenda. We're first going to be talking about what remote WebDriver is. Then again, JSON wire protocol, the basics of all WebDriver communications. Then we're going to be talking about the desired capabilities, what they do, how to handle them. Augmenters, they're going to be talking about special cases for local files. Even though you're running tests remotely, WebDriver handles it pretty nicely. So we're going to be covering that. And then it's just going to point you to the API docs and where the code is, because Selenium is open source, and you should be reading the source code. All right, so first of all, what remote WebDriver is and how is it different from Firefox driver or Chrome driver or any of the other drivers? Basically, remote driver is all drivers. The remote driver can drive any of the other drivers remotely. It's basically a wrapper that lets you separate your test scripts from the machine in which the browsers are going to run. I just took this from the wiki, not that I wrote them myself. Basically separates your tests from where the browser is running, which is pretty clear. You can still run remote WebDriver locally and run your tests locally, but the most value you get is from running the hub somewhere and your test somewhere else. And of course opens the door for the ultimate solution, which is Selenium Grid or Sauce Labs, which is a hub that will be able to run browsers in parallel in multiple machines. So any mature Selenium environment with a lot of tests will need speed, and what is meant to address that is basically keeping your scripts in a single box and handling all the high processing in separate boxes in a grid. The disadvantages is that it takes a little bit more of setup. You got to understand all the moving parts, which is what we're going to try to address here. And it also introduces extra latency between your scripts. And it introduces latency in your scripts because there's an extra communication that needs to happen between your scripts and the remote server. Depending on how far or how close they are, the time will change. But you got to be aware of that. It's also worth pointing out that everyone moves to grid aside from that latency, and it's basically because the huge improvements that you get from running tests in parallel way overtakes the extra time that it would take for like the couple of milliseconds that every command will take additionally now that it's going through the network. So let's kind of check an architecture diagram of how the whole thing works. This is super simplified, but should answer a couple of questions. So what you can see here is the separation between the machine in which the test script is running. This is basically a Java, Python, Ruby script running in your computer, its own process. And as soon as you start running it, it will communicate through the JSON wire protocol to a remote process, which is a Selenium server. And all the heavy stuff is going to be happening in the Selenium server. It's going to take care of booting browsers, passing the baton back and forth between your script and the browser with things like trying to find elements or pulling for elements value or stuff like that. Of course, this doesn't need to be the internet. This could be the same machine. This communication is done via HTTP. So you could have a localhost Selenium remote server running, and you would point your libraries to localhost. Of course, latency would be way smaller if you did that. You could also have a computer inside your LAN and point it to there. One of the demos I kind of wanted to do is to be on the same Wi-Fi and have my computer run the server and someone else run a script. I didn't get to set that up, but basically you can point it to whatever address you can hit. If it's through the internet, there will be more latency. If it's in the same LAN, not so much. And if it's locally, of course, it will be super fast, which is probably what you experience when you do regular drivers like Firefox driver or Chrome driver. And what they do in the back is basically this whole setup. If you start Firefox driver or Chrome driver, what they will do is like start a wrapper of the Selenium server in your computer, start a browser, and then hit it. Depending on the driver implementation, like Firefox has the web server by itself, Chrome has a separate process, but this is what's happening behind the scenes. Remote driver is the only one that actually requires you to do it yourself. So let's go to a basic demo of this whole thing, and then I'm going to do it step by step. So first of all, I have the Java process running, starting Selenium server. It's in my local computer, of course. Let me show you the script. This is Python code. Let me actually make it even bigger. All right. So it's wrapped in a test case class, basically because of the setup on the teardown, which is not really necessary. So what you can see here is the instantiation of the remote driver. First of all, we choose the capabilities that we want the test to use. Right here, we're using the bundled Firefox capabilities that we get in the library. And then we instantiate the remote driver and point the client to whatever the remote driver is. In this case, it's localhost 4444, which is the default port that Selenium uses. And then just basic Selenium WebDriver code. We just get a URL, assert the title. I added a couple of sleeps here just to make it easier to watch, because otherwise it just happens too quickly. And then we just get a couple of elements and type in them, and then click on the submit. I should probably make this a little bit more object-oriented and not messy procedural with things like submit.click and submit equals. But you get the point. And then we just quit it. So I have running the server. I just hit my test script, and hopefully Firefox will just open and run my test right in the middle of the screen. All right, we got some live demos like us today, so it seems like everything's working. You just open the page, again, types username, password, nothing too fancy. You've seen Selenium already. But there's something special about this than what a regular Firefox driver is, and it is that I could have been running this process in whatever computer, yours computer, and my computer would only process the Python code, not worry about browsers. I can run this script from a Mac and heat a computer with IE and run a test in IE, which gives us a lot of possibilities. So step by step, what you guys need to do to make this happen. First of all, you need to download the Selenium server. To do that, just go to Google Code. Right in the project homepage, you'll see a download section. You can either click it right here or go to the list. The one you're interested in is Selenium Server Standalone. It's just a jar that you run with Java, and that's the whole magic. If you're interested in something more fancy, like running it from Java and configuring it, you can also do it. But this is the easiest way. So once you download it, you start it via Java. Then you write your scripts, choosing the desired capabilities for this test. Then you point Remote WebDriver to whatever location you run the server on, and then it just happens. So you kind of saw a big part of it. Let me show you how you actually localize this. In this case, it's running on port 4444. So if I run it, it will tell me which port it's listening on. So you get it here, started socket listener on 4444. Of course, I could change that port. I think it's using -- port. If I change my script and point it to localhost 4449, it'll basically fail and tell me that connection was refused. It couldn't find the server right there. So make sure you're finding the right box. If you are running on a separate computer, I would have to get my IP. So my IP right now is 10.0.2.2. So if I were running the script in your computer, I would basically hit that IP, and it should be it. It should basically work if all the network and firewall rules are well set. So let's now talk about the internals and what actually made this happen. What made my script running in a process connect to a separate process, run a browser there, get the responses back, and how the whole coordination happened. So this whole thing happens due to the JSON wire protocol. It's the protocol that the Selenium project invented for handling all the communications back and forth. It's kind of like SOAP, but doesn't suck. It's JSON over HTTP, and it's pretty RESTful. That means that it uses the HTTP verbs, and it's kind of syntactically correct for the commands that it's trying to send. It's good to understand also that the intent of your test is going to be in your script and only in your script. Only the API calls, just plain API calls, will go through the wire to the Selenium server, and we'll talk a little bit more about that now. So basically, the internals from your script to the Selenium server are, first, the WebDriver API. This is what you handle. This is the object-oriented API that you use when you do something like driver find element by ID and returns you an object, which for you represents whatever element you pull, let's say an input field. And you have this variable that represents the input. So you can do things like call send keys inside this input, and somehow it'll connect to the server and tell it to act on this input. And you can click around with them and just pull more stuff. This is all, there's a lot of conversion process for that to happen. First of all, the WebDriver API is converted to a WebDriver SPI, which is basically a more raw Selenium RC stylish API. It's more functional. And this is because the JSON wire protocol is stateless. I don't know if you know HTTP, but there's no active connection all the time. There's one request and one answer, and we forget about it. And then there's another request. So you got to keep state between one and another. And everything has to be disconnected and procedural. So with the WebDriver SPI, basically converts into the JSON wire protocol. I mean, the JSON wire protocol is basically an implementation of the SPI. And that's what the Selenium server gets. So let's look at an example. This is, again, Python WebDriver API. It's pretty much the same like it would be in Java without some icon that you get from Java. You first use the driver to find an element. You store that element reference in a variable, and then you act on the element. So what actually is happening on the backend inside the API is we just call a plain find element command, sending, of course, both parameters, the ID and the value of the ID expected. And then we just call the basic send keys, telling which element we try to send the keys to. This is pretty RC style. I don't know if you've done Selenium RC, but the syntax is pretty much like that. You have a browser object, a Selenium object, and you just have all the methods there. The API is just huge. You call type, and then you tell it which locator, and then you tell it what you want to type. And it's just plain, always acting on the Selenium instance. While in the WebDriver one, you can get a little bit more fancy and get references to elements and iterate over elements and things like that. That makes the test a lot more readable and powerful. Now, let me show you what the WebDriver JSON wire protocol looks like. This may be a little bit scary, but let's see what you think. Let me try to highlight some of this stuff. There's no syntax that I could use, but this kind of helps. So the script that I'm going to be dumping here, I basically run this script and dumped all the network traffic back and forth. So this is the through the wire representation of the script, and this is the script. So the first command that we're going to see happen is the instantiation. As soon as you instantiate the driver, it'll make a request to the server asking for this browser that you're asking, in this case Firefox. And it'll wait for a response from the server confirming that Firefox is ready, booted and ready for you to use. So the first command that we'll see is going to be a post to the following URL in the server, so /wd/hub/session. And it will send all the desired capabilities that you have. We're going to cover desired capabilities in a minute, but it's basically what your test is looking for. So the server can give you any browser, so you got to tell it which browser you actually want. So you represent it giving a browser name. In this case, it's Chrome because I run this script using Chrome, but it should be Firefox. And it tells some extra configurations that you may want for Firefox. In this case, it's pretty plain. It could have been, I want Firefox 11, and I want a platform. I want it to run in Vista. Nevertheless, you just send a post with a body of the desired capabilities to the following URL. And here's the response from the server. The server says, OK, I just got you a browser. Now follow the following redirect to start running your test. So you get a 302, which is an HTTP redirect pointing to the following URL. So that's what the next HTTP interaction is going to be. You make a get to that URL. And basically, you send nobody because it's a GET request. And basically, what you get back is desired capabilities. So you request for a browser. The server gives you that browser and then tells you, OK, go here to find your session. As soon as you go to that session, you get a dump of everything that you got when you requested it. In this case, I was running Chrome, so I get information like what the Chrome driver version is right now, the one that I got. Of course, repeated stuff like the browser name. I also get stuff like whether it accepts SSL certificates and other technical information, like actually what platform it's running on. In this case, it's XP. So that's just the first command. As you can see, this is pretty loud, and there's a lot of stuff going back and forth through the wire. You're not going to use a lot of it. The project tries to keep the API as clear and reduced as possible. But if you want to go hacky and pull the capabilities and start playing with them, you can. I'm going to tell you about that in a minute. So second command, we're trying to get the following URL. We're trying to go to saucelabs.com/login. In here, you'll see that represented as a post again. We're going to post to the right URL, which is, again, /session. From now on that we have a session, we will start sending commands right after the session. So we keep that URL always fixed. And that's what tells the server which browser you're talking about. A server can serve many browsers at the same time, depending on the computer where you're running it. So you could have 2 client libraries and a single server on top. And you could both have a session running at the same time and asking for different commands. The server will handle both browsers. Depending on the browser, it could be a problem. But for example, I know Opera 11.6 and the latest Opera driver can handle multiple Opera sessions in a single computer at the same time. I don't think we can say the same about IE, but I'm pretty sure Firefox and Chrome kind of do the same. So once we have our session, which is the first thing that WebDriver returns, we're going to start sending commands using that, identifying the browser as that session. So we call for a URL, and in the body of the request, we send the URL that we're looking for. The Python client binding also adds a session here. I don't think it's necessary. I don't remember whether you need to have it in the URL or in the body. But the important part is that we're sending the URL here. And the server basically responds with a 204 saying, all right, we just opened the URL you wanted. Everything's fine. Next command, we're going to request for, actually, I added this later. I don't think the title is going to be there. We're going to do a find element by ID with username. So what's going to go through the wire once I do that is another post. It's going to be an HTTP post with /element, which basically in JSON wire protocol means find element for me. And the body is going to be the information that we just talked about, which is what are you using to locate the element and what is the value of that, that identifier. So we're saying, hey, I want an element located by ID, and the ID has to be equal to username. And the browser in the server, in this case, once the element is located, it will return a body saying status equals 0, which in WebDriver and JSON wire protocol terms means everything went fine. We just found the element for you. And the value of the response gives you the element identifier. In this case, 0 is the number of the element that we just got. So now that we have an ID for this element, oh, sorry, this is not it. Now that we have an ID for this element that I just have highlighted, let me make this more clear, more object-oriented. So now that we have the username saved, what the WebDriver API does is basically correlates that identifier to the variable that you now have, the web element variable that you now have. So when you call username.send keys, what's happening is WebDriver does another post. Now, here, does another post saying, change the element 0's value. So /element/0, which is the identifier of the element that I got just returned, and then value. And I'm basically going to give you the following value, which is an array of strings. So type username in that element for me. And WebDriver returns true, and the whole flow keeps on going. It's the same thing. I pull for another element, I send the keys. But as you can see, what you see in the JSON wire protocol is more like Selenium RC. They're all plain commands, and we're just telling identifiers over and over and over. This also leaves for the possibility of stale elements, because you can pull an element at first, keep your test going, maybe the browser can navigate to a separate page, and then you try to act on an element, you try to use that identifier, and when WebDriver gets to find that element again, it's not there anymore. So you get a stale element exception, which never happened in Selenium 1. And it was simply because you had to do a search every single time you acted on an element. So you did some like type this locator and this value. You could get an element not found, but it will always search it brand new. So this is basically what you get in the JSON wire protocol. And I hope you got the idea between object-oriented versus just plain simple stuff. Oh, something else that I kind of wanted to cover in here is how the intent stays in my test and only the actions go back and forth to the server. So if we were to look at the following command, I'm basically trying to assert that the title in the page is login sauce labs. If you run this command, what goes through the wire is not this, and it's not that you're waiting for that to be the value. You just get a request for the title. It's clear once you understand JSON wire protocol and why it's that way. But basically, the intent, if you get a result that is not that title and your test fails, there's no way that the Selenium server understands that happened. The Selenium server is just an automator. It gets a request, passes it to the browser, gets a value, sends it back, doesn't care what happened. If you close the session, it closes. If you don't, it stays open. So it will never understand what happened in your test. And this gives you security as well, because your logic is only in one location. In the other location, the remote server is just getting plain actions and requests and looking for information. So you can keep your logic locally, and you don't really need to send scripts remotely for them to run. You just keep everything locally. And what happens outside is just an automator that responds back. Now, any questions so far? Or should we go? Actually, let's go for a Q&A at the end. If you feel like your question is going to be too out of scope later, raise your hand. We'll see what happens. Yeah.
How do we do, like, if we want to configure, we need to talk to more than one machine? So it's just that where you have written localhost 444?
That's a great question. How you do that? The Selenium Grid project solved that for you. The way it does is you will always still talk to a single machine, but let me see if I can go to the architecture. I kind of wanted to talk about this anyways. What happens is you would have a load balancer in front of the Selenium server. So you would have multiple of these guys here, here, and here, and you would have a single machine that distributes the processes back and forth. So for your test script, it's only one machine. You don't care. You just talk to that guy. And you talk several times in a row. You just ask for multiple browsers, and that is the one that is going to take care of, all right, this machine is busy. I'm going to send it here. And this one is busy. I'm going to send it to this one and just coordinate the whole thing. The Selenium Grid project does that, and it's embedded in the Selenium server already. And at Sauce Labs, basically what we do is put the same interface that Selenium Grid does. We just place a hub. You always hit saucelabs.com. Doesn't matter which browser you want. Doesn't matter how many tests you want to run. You just hit it 45 times, 200 times, 250 times, and we'll get you all the browsers and give you all the right responses and coordinate the whole thing. Yeah?
So in this picture, I see what I think is the standalone server. I see my test script. But you said there was an additional server needed to use Remote WebDriver. Where is that in this picture?
The additional server is the Selenium server. This is the jar that you need to download and run. This is not new for anyone doing Selenium RC. For Selenium RC, this was the only way. You had to run the process. You had to run your scripts. With WebDriver, it was awesome because you just run your script, and your script boots up the browser without any additional processes, which was basically a wraparound the same concept. They just started the server locally and did the whole thing by itself, which put a lot more work in the client bindings than what RC did, but it works really well.
Just a quick question on the wire protocol.
Yeah?
When do the element IDs cycle through? Like you get there's
how do you
ID?
Yeah, how do you shut down a session?
Is it local to a session? So it's always increasing on it per session, or does it reset?
Oh, yeah. The ID is only by a session. So if you have two browsers, you're running two tests separate, you will have element 0 for this test.
So does it recycle when you go to a new page?
Yeah, it's just incremental, guys. Okay. I think it's always incremental. I have to confirm that. But yeah, I think if it navigates or eventually detects it, gives you back a new ID. I'm not completely sure about how that works. So let's talk about the desired capabilities object. Basically, what the desired capabilities are is just a hash. It's just a JSON object with key values of what you actually want. So it's sent to the server from your script. If you're trying to run Firefox, the browser name will be Firefox. If you're trying to run IE, the browser name will be IE. If the server has it, it will boot it and confirm. If it doesn't, it will fail and tell you that that browser, those capabilities can be met. So the server uses it on the other end. And once it boots a browser, it actually returns back saying, all right, I booted this browser. This is the additional information about it. So it can be a little bit general when you request a capability. You can just say, I want Firefox in any platform. And then the server will tell you, OK, I got you Firefox 11 on XP or Vista. Most people don't really care about what you get, but there's a lot of situations in which you actually pull the capabilities and confirm whether you can capture screenshots in this browser or whether you have JavaScript enabled or not. Actually, this is pretty recent. We set up a wiki page with all the desired capabilities available. And you can see that there are a couple. There's per browser capabilities. So you have things like Chrome binary. You can define where the Chrome binary is. And it doesn't matter if you're running Firefox that you provide that. Of course, a lot of these are just optional, but nice to have if you want to go into a lot of detail or if you're running into issues that need this to be very specific. And it's also worth pointing out that capabilities are not just for choosing one browser, but also for configuring the browser. You get to choose Firefox 10, but you can tell Selenium whether you want, let me think, whether you want a proxy or not. It's just configuration additional to Firefox. If you don't request it, it will be default, But if you do, you're going to set up the browser a little bit better. You can send profiles and stuff like that. Now, this is a basic example of what the capabilities do. So you, and this is nice that the Selenium, all the client libraries come with a prefixed set of capabilities. So you just get if you call this, you're going to get a preset Firefox request capability. It's just an object with the basic Firefox stuff. And I see this as this is kind of a joke I wanted to add because I thought at this point I didn't have any images. So it's basically like ordering coffee in Starbucks. I'm from Argentina, and I'm amazed at how people order coffee here when they go to Starbucks. But you can go as detailed as you want. You can always be like, I just want Firefox, or you can go down deep and be like, I want Firefox 5, and I want it on XP, and I want the proxy to be set to this location, and you can always be more specific. Selenium even has things like platform.any or platform.xp or platform.windows. So you can go to several levels. You don't care if it's Linux or Windows. You don't care if it's XP or Vista, or you don't care at all and give me whatever. So in the same way I said it's just a hash, you can also print it. And I find this is extremely valuable when you're running into issues. You just have this object, you're not really sure what it contains, and what is going through the wire to the server. Sometimes you request Firefox and it doesn't work, and it may be because you're not using the right key for Firefox as a value. So you can always just print it right away. So let me show you how I print it in Python. At this point, I think you notice that I'm a Python guy. So I'm just going to do it in a REPL. So let's choose Firefox. So now if we print C, actually I don't even need to print C. If I just output C, you'll get the actual object, the actual capability hash that I'm requesting. You can see here that basically it is browser name, Firefox, JavaScript enabled, true, and any platform. So I can go more detail and say I want C platform to be Vista. And now if I output C, I'll get it changed. And I can add additional configurations to that. And that is basically what is going to be sent through the wire and to the server. Now, let's dump what the server gives us back. So I'm going to do something like D equals, and I don't call my variables D. I'm just doing it for brevity here. So don't judge me. So remote, I think it's command executor equals, I'm going to choose localhost 4444 wd/hub standard URL. And then I'm going to do desired capabilities equals C. So let's see what happens. I just call WebDriver. I'm hitting. You can see that this is taking a while, and it's basically because it's hitting the browser, the server, and the server is booting a browser, and it's taking a while, and it won't get back until it actually boots it. So now D is ready. Now I have the driver here, so I can do driver dot get google.com. If I check Firefox, you'll see that Google is open. And now I can do driver.title. And you get that the title is Google. Now, what the real capabilities in this browser are, you can find those in d.capabilities. And this is what the server returned. There's a lot of information there, actually. You see the browser name that I requested, so that matched. Now you see that CSS selectors is enabled in this browser, which could be very handy in your script. If you have a really complex script that depended on CSS, we'll now be able to check whether that's present, and if it's not, fail prematurely instead of going through the whole script to find it later. You can check that it handles alerts, that JavaScript is enabled again. You can check that it doesn't have native events. And it also gives you useful information like which the current version is. So version 11.0, which is what I have installed. So you could use all this for reporting. If things fail, you don't really have to keep track of what your machines get. You can always just print the capabilities as soon as your test is over during the teardown. I find that super useful when I run tests in a lot of browsers. And I also find that useful when customers want to ask me what we have installed in sauce. We have our own internal list of things that goes pretty detailed, but just doing this gives me the real thing, what you actually get in WebDriver. When you run it in Chrome, you also get the Chrome driver version, which is really handy as well. The Chrome driver is a special server used by Chrome driver to drive Chrome, and there's several versions, and depending on the versions, there's things that are supported, things that are not. So getting the version is actually very useful. Now let's talk about augmenters. I'm definitely not the guy to talk about augmenters, but I thought I should bring it up because it felt kind of important connected to Remote WebDriver. If you guys are doing Java, first of all, I'm sorry for you. Second, in a lot of cases, you will need to do this kind of hackery to augment your driver. So this takes the capabilities concept the right way, and basically when you get a remote driver session, it won't have methods like take screenshot because there's a lot of drivers that actually don't, a lot means one, which is HTML unit, that don't have take screenshot. So what Java does is it gives you the option to augment your driver. So you call this, you just copy and paste this in your code, and it will augment it and check the capabilities. And if the capability for taking a screenshot is present, it will extend your driver. Probably not using the right terms. And then you cast it to take screenshot. And then you will be able to get screenshots from the driver. In most of the other implementations like Python and Ruby, I don't know if they do this magically because the languages are more dynamic, or they just add, I think Python just, let me not guess, let's figure it out later. But I would guess that they just give you the method every time, and if you call it, you get an exception. The fancy and nice part about this is that if you try to augment it, you can check whether it's augmented already. Hence, look. You basically can check before you hit the exception, so you can make your test really, really, really smart. Now, you will say, I'm running tests remotely. The browser is running on a separate computer that is not mine, but I have a lot of tests that actually need to run in my computer because there's stuff that is not present in that box that I need to use. A good example of that is profiles. When you run a test locally with Firefox driver, you have a Firefox profile class that behind the scenes, it basically creates a profile directory, and it fills all the files for Firefox to boot using that directory as a configuration. And you can configure things like whether you want a certificate exception or whatever you can configure in a Firefox profile, basically everything in Firefox. Now, when you do that remotely, how does it happen? Because you still have the Firefox profile class locally, and you don't really want to send every instruction through the wire back and forth so that the server does it for you. So the decision they've made for this is basically to handle the file locally and then base 64 encode it, which means zip the file and make it a string, and then send the whole string through the wire to the other end. And in the other end, it will be decoded and unzipped and put as a directory and used. So it's pretty hardcore what's happening in the back end, but it makes it so easy and transparent for the users. You just don't care. In the same way you use Firefox profile for the Firefox driver, you use it for Remote Driver, and it just works. You never wonder what's actually going on. But there's a lot of work behind it. Again, worth pointing out, if you're running this through a network, the internet, whatever, the size of this is gonna be related to the time that it takes to run it. We're not talking about minutes. We're talking about milliseconds. But be aware of that, because when you run tens of thousands of tests, you'll notice a difference. So don't complain, you're still getting a lot of stuff out of it. Now, how about file uploads? Well, the concept is similar, but the Selenium developers put a lot of work to keep the API as simple and brief as possible. The way you do it when you have a local driver, like Firefox driver or Chrome driver, you basically just send keys with the path to the file, right? So if you have the browser running locally, you find whatever file input you want to type to, and you just type the whole path, and it just works because the browser is local. It will find the file locally and upload it. Now, when you're running in a remote driver, you can't just write your local path. It's definitely not going to work. So the way they made this happen without affecting the API, it's a little bit hacky. There's a lot of ways to gain control and make it the way you want it. But out of the box, that's what 90% of the users need. So what happens is 3 steps. First of all, WebDriver detects that you're trying to type a path by checking whether that string is actually a path and there's a file located in that path. If it detects that you're trying to type an existing file's path, it, again, base64 encodes that file and it sends it through the wire with a special upload command. So far I didn't type anything. It just found the file, sends it encoded to the other end. WebDriver receives that, decodes the file and saves it locally, and responds back with the new path. It will tell something like /temp or temp directory in Windows or whatever. The file is located in this new place. And the client library, just in the single call, you're not doing anything by yourself, now sends a send keys with the corrected path. So you're running this in your test. In the back end, it's actually a lot of things happening. Uploading the file, getting the new path that is in the remote computer, and then typing that remote file. So when you watch the video or when you watch it run it, you're trying to type this path, but in the remote computer, it's going to be something like /temp/myfile, and it's going to upload it. How you do this? How you tell WebDriver to do this is by setting the file detector in the remote driver. And I have investigated this for SOS and some of our customers that depended on it. And I was also super interested in how they managed to implement this because I felt the pain of the way Selenium 1 did it. So let me take you to the Java version, to Honor Java, which is the main programming language for Python. Basically, what you do right here is this step, set file detector, and you tell it to be a local file detector, and that's about it. Now your script will just do the whole magic for you, and this line of code, which is uploading a file, will just work. You won't even care about what happened. So if you now try to run this test in Firefox driver, you just remove these 2 lines, the file will still be located there, it will just type the path and don't do anything additionally. So it's pretty awesome the way it magically does the whole thing for you so that you don't have to worry about it. Now, I really like the approach that the Ruby bindings took. They let you implement the detector with your own code block, which is Ruby stuff for Lambda functions or named functions. So basically, you tell it what the file detector should be. In this case, you just tell it to use file.exist to tell you whether it exists, and if it does, it just returns a string. And if it, yeah, I don't remember how, let me see. Yeah, the file detector will return either a string or null. So if you return a string, it means that the file is there, and WebDriver should do its magic. And if it returns null, it means that there's no file, and you should just type the original string. So this is pretty cool, because you can do stuff like implement your own detector and use coded file names. So you could use something like a special string, like : file upload, colon, dark bulb, or whatever, or my file. And in this function, you would basically match that code to whatever location you want. So you can go a little bit more fancy. In Java, it's the same, but you just have to implement it, implement your own file detector and stuff, which is a little bit more painful. Now, the API documentation for all this is, of course, linked in the Google Code page. So you can just go to code.google.com/p/selenium, and you'll get all the links right there. I took the work of finding exactly where the remote code is and pointing it there. I'm going to show you in a minute. So here's what you're looking for, the user documentation. The first one is Selenium HQ, which is a lot of, it's kind of a manual taking you through the process from getting started what Selenium is to WebDriver and how to use it and how to use Remote Driver. And then the others are just, I don't know if you've seen API documentation already, but it's basically a dump of all the classes and all the methods available per class, which is pretty useful when you start using the classes a lot and looking for methods, and if you don't have an IDE, that does it for you. So I really want you guys to start reading code. The Python code is, the Selenium source code is a good example. There's code for everyone. There's code in .NET, JavaScript, Java, Ruby, Python, whatever you're looking for, you'll find code in the Selenium code base for that language. So, actually, oh, I'm actually going to bring that up in a second, not now. So where's the code? Again, I want you guys to read the code. And to read the code, you go to Google Code and check it out. You can use SVN to check it out, or you can just use the web interface to get it. The Selenium repository is quite humongous. That is because there's so many client libraries, there's so many drivers. Every piece of the whole combination, every piece of the whole infrastructure is its own piece of code and it's implemented differently. Even though there's a lot of reuse, you'll notice that the JavaScript one is huge and the Java one is big as well. But in this case, you can just click around the files or you can navigate yourself. For example, let's look for the Ruby implementation of Remote Driver. So you go to Selenium, navigate to trunk, and then live Selenium, WebDriver, and I'm hoping remote will be here. And that's about it. You just got to remote. So when you click on bridge, which I believe is the implementation, you get to the whole source code. So if you're looking for a method, you can come here. If you're trying to understand how the whole thing works, where the session ID is stored, where the element identifier is, you can find it here. The code is super, it's just pretty easy to read. I find that remote bindings are a great place to start learning how to code and how things work, because there's not that much complexity to them. They're just a plain wrapper around JSON wire protocol. So it's a pretty good place to start. And you can find things like where the capabilities are, where the session is stored all the time. And if you want to pull the session, you can do it. So for example, here, you get the session ID and the method for that. So again, go check out the code. Depending on the client library or the language you feel more comfortable with, just go there, check it out, try to contribute or implement stuff. There's also some other languages implemented. They're not official. That means that the guys working on them are not part of the Selenium development team, or at least the ones I know. And what's most important is that they don't keep track of every release and they don't match all the features that are currently available in every release. But there's like 2 or 3 PHP implementations. I think the guys at Facebook were the ones that started implementing the PHP driver. And Adam Goucher has been working on them as well. There's some other implementations. There's a Perl driver. I know there's a Lua driver. So if you guys want to use your programming language and there's no implementation, it's pretty easy to do. It's just going through the JSON wire protocol spec and making that happen. If you want to check the JSON wire protocol spec, it's big because there's a lot of actions and commands happening, and it's really, really detailed. So the way you do it is just go to the Selenium wiki and search for JSON wire protocol, and you will see every single command and the URL that you need to use to implement it, and then an explanation of what happens. So for example, let's just click around. If I want to do like set the implicit weight, the way that happens in the backend is basically a post request to the following URL, and the parameters that are being expected are the session ID and JSON body, which is going to be the milliseconds, the number with the milliseconds of implicit weight that you're trying to set. So basically, if you want to implement a client binding, all you need to do is just come here, read the whole spec, implement it in your programming language. It's not that hard. Most of the people do something like a command processor, and all the methods are just plain, like calling the command processor with the word that you're looking for. So they're super, if you go, here, you'll see that basically all the methods are just simply this. Refresh will execute refresh, close will execute close, and then you have a big class which is going to be the command executor, which is going to take, in this case, is execute by itself. Well, there's another raw execute, and this is the guy that is taking care of all this stuff. It receives what the command that you want to do, and it does all its magic. Makes sure there's a session, uses a session to build the URL, and then finds actually what command you're trying to use for that method. So read the code. It's really easy to read. It's really easy to write your test if you have the code open right there. So just get the presentation and follow these links, or navigate the Selenium repository. Now, questions. You guys have any questions?
While the tests are running on the remote host, and if the network goes down for a sec and comes back again, does the WebDriver look for the network to come back up and then continue the test, or
yeah? Every command is waiting for a response. There's never like a sending something and ignoring. That actually came up in the IRC when we were talking about this presentation, and I had some people help me and give me advice, one of which is Luke, and I don't know if any other guys are here. But basically, every command is sent to the server, and the connection stays open until the server responds with the proper HTTP response. Even if you're running something that would never fail, like setting the implicit weight, you're never actually expecting a response. It's always going to be a 204 saying, OK, I just got your request. You still get a confirmation, because there's a lot of situations in which the server could be broken or could not even handle that, and you get different error responses. You will get, most of that stuff is handled in the body of the response, so you will still get something like a 500, and inside the body you'll get a status that is more detailed and tells you exactly what happened. And it's fun, you can see that. Let me go into that because it's actually useful. These are all the status responses that the server will give when you request for a command. These are all going to be inside the JSON body. You will try to kind of stay in sync with HTTP. So if the command went well, it will give you a 200, HTTP 200. If it failed, it will give you a 500. But then it will need to go into more detail and tell you things like timeout issue, or lookup error, or stale element exception, which I expect is going to be somewhere here, like 10. So you'll get, I don't know what the default, I think it's going to be a 200 HTTP, and then you'll get this status to be bad. And this is the one that libraries care the most, not really the HTTP one. There are some details, like HTTP 400 is going to be plain text always, and 500 should be JSON and things like that that the protocol chose. If you guys disagree with the protocol, I definitely definitely invite you to join the IRC and talk about it. Simon is super friendly, not so much when you come with suggestions for changes, but is definitely friendly and would be happy to explain you why he chose all these different and made all these different decisions. So yeah, I think that answers the question.
Can we run on multiple hosts at the same time?
Huh?
Can we run the test on multiple hosts at the same time?
You can, no, you can't, because the client libraries are not prepared for that. There's a lot of coordination for something like running the same test in multiple hosts. First, some hosts will run steps faster than others. Second, some steps will pass in one server and fail in others. And you gotta do a lot of thinking on how you wanna handle those situations. The protocol is not prepared for that. I'm pretty sure you could create your own library that could do that. Basically just spawns requests for 5 servers, waits for responses. You gotta make a lot of decisions on how you wanna handle differences between one and another. But you'll get things like one command taking 5 minutes and another one taking 10 seconds, and you gotta keep that kind of all consistent to be able to keep the flow. I was gonna say something. It's important to know that when you run tests in Remote Driver and things fail and you get an exception like this, the whole exception comes back with a screenshot, which is really useful. Selenium basically takes a screenshot in the remote server, base64 encodes it, and then sends it as a string in the response, which is great a lot of times, but people don't use them like 99% of the times. So it could be a problem because they add latency. We're talking about full files that go through the wire every time there's an exception. And people raise exceptions a lot of times. There's times where you want to check that an element is not present. So what you basically do is just find element, find element, find element until it disappears, or until it appears. And every time you do that, it's going to pull, and you're going to get the whole file. So it adds latency every single time. So tests could get slow. At SOS, I think there's currently no capability that fully disables automatic screenshots on all drivers. So at SOS, we just had to solve the problem for a customer. So we just went ahead and created a SOS-specific capability, and we just intercept the request through the wire and drop it. But if you guys are doing your own thing and you want to speed things up, you see that things are getting slow, maybe you have your data center in different geographical location and you have to go through the internet, that could be one of the problems you may want to look into. There.
I have a follow-on question to that. Let's say you're using a single host and you want to multi-thread multiple browsers. Is that possible?
Yes. As far as the host can take it, are you talking about a host holding the server?
Yeah.
Yes. If the host can take it, it can boot as many browsers as you request.
Simultaneously?
Simultaneously. It can follow all the sessions separate and receive all the requests at the same time, respond each at the right time. Of course, you don't want to do too much because you could start running into resource exhaustion, like running out of memory or whatever, running out of processes. But a lot of people, I've seen people do it for like 40 browsers. I've seen people that instead of doing Selenium Grid, they basically booted 40 Selenium servers. They could have done only one, but the Selenium server itself may run into memory leaks eventually. So they booted 40 Selenium servers in different ports and hit them all, and they will all boot up browsers. So if you look at that desktop, it was just awesome. You see like 40 browsers doing stuff at the same time in different places. It really depends on the machine limitations. I also wouldn't advise you to go down that path because I find that machine state is a big source of problems when you start running a lot of tests and your build gets more mature and you try to make it not flaky. Machine state, by machine state I mean the current state of the RAM, the current state of the CPU, the cookies, how the browsers are, the amount of processes running, disk space, I don't know.
Browser shutdown, is that clean?
Huh?
Browser shutdown when you're done, you have to do that yourself, or is it clean?
No, Selenium cleans stuff up as much as possible. There's a lot of situations in which I've seen it fail. Some cookies still there, or I'm also talking about Selenium 1 and Selenium 2. You could go into issues. What we found to be the strongest solution for SOS is to not even reuse a machine twice. So if you drove a browser in this box, we basically discard it and get you a new one because you get brand new memory, the OS booted right from zero, so you can reproduce a failure over and over because you get exactly the same machine. There's still some randomness that you never are able to deal with, which this is just at different levels of the OS, but you can get the most pristine machine and the most reproducive environment using that kind of thing. Just discard the VM, get a new one in the same state, run the test there, and you'll be set. If you run 100 tests one after another, I mean, 1,000 times it will be fine. If you run it 2 million times in a day by running 100 builds that run 1,000 tests, or I don't know what the math is, but eventually you'll run into trouble and it will be hard. And when you start adding flakiness to your build, that's the worst you can do because developers are going to stop believing in the build and they will just rerun it every time it fails. And that takes everyone's time and that introduces bugs in production, which you really don't want to do.
How many garbage collecting uploaded files, particularly in the case of unexpected failures?
I don't think there's garbage collection for files. They are put in a temporary directory. If you fill the disk, that could be a problem. I wouldn't expect that to happen in like a pretty normal VM, unless you send something like a gigabyte big file through the wire. And I think the disk space is the less you want to worry about if you do something like that, because it's going to be a lot through HTTP, probably going to fail.
Yeah, I guess that's fine if you're doing what you said, which is destroying the entire VM this time.
Yeah. I would say, here's my answer. Go ahead, check out the code. The server is Java. If you see that the file is not being cleaned, which I'm pretty sure it's not because the upload is disconnected from the command to send the file through the wire is disconnected from the command used to type the path. So I'm pretty sure Selenium would respect it and just keep it there in case you want to use it later. I would be really surprised if it cleans it. Maybe when you kill Selenium, it destroys the whole directory.
Maybe when the session ends. But
yeah, exactly. Maybe when the session ends. That's a good call.
Data and it's actually important information for a company and you want to send it off into the grid.
Yeah, you got to trust in your own grid or... Yeah, well, yeah, we promise we destroy the box. It's the best I can do.
So I used to use Selenium RC a lot, before, and I just recently switched to WebDriver. One of the things that I found missing was apparently the way you specify a browser to run is through the capabilities object, right?
Yeah.
So it's going from the client to the server side. But there is no, I didn't find any capability that you could set on the server side to
default
to suggest what browser to use, or those kind of configurations.
I don't think I never needed something like that, but I would be surprised if there is. Yeah, you could do that in Selenium.
I know that if you want to use Chrome, you have to tell the Selenium server where the Chrome driver jar is. So maybe if you tell it to use a Firefox jar or an IE jar or something like that, then it will default to that.
Isn't that sent from the client side, though? In the capabilities?
No, that's part of starting the remote server.
Yeah, no, I don't think it would default. You kind of basically tell it, because the Selenium server sometimes needs additional stuff, like what you're saying is the Chrome driver server, which is an additional binary. Nowadays, it tries to find it in the path, or otherwise you got to give it the right location. I don't think it changes the default. I'd be surprised if it does, because it's kind of two different things. I don't think it can change the default. In Selenium 1, you got it. You could just basically set override any request and just do this browser. If you want that for Selenium 2, you can start by just going to the source code and try to implement it yourself. Talk to Simon why that's useful and why that is a general enough case so that it makes sense to do it. It's not that much work, I'm pretty sure. It's just basically starting the server with a parameter and get it going. You're welcome.
So if I get this whole thing right, to my old scripts in which I've written RC, we just go ahead and set it to the WebDriver, at the top of the script and all my tests tear down. So that is it, right? Nothing more we need to do.
Sorry, I didn't get the full question.
So the question is mainly about migrating the old scripts from RC to the WebDriver.
How can you move that? How can you make that happen? There are several ways. I generally tell people not to do the whole move as a project. Don't spend 6 months rewriting all your tests. That's pretty painful, and it's going to take you a lot of time, and maybe the return of investment is not that big. If your tests already pass, that's a good thing. It's something that I wanted to cover, and I did it. The Selenium server jar doesn't just do WebDriver, but it also does Selenium 1 at the same time. It's kind of this magical thing. It listens at /wd/hub for WebDriver request, JSON wire protocol. And it listens at just, I think it's /selenium-server for Selenium RC request. So it can handle both at the same time. It's pretty ridiculous that you can request like a browser with WebDriver at the same time request a browser with RC. It will handle both, run the scripts in both, and then return results and do the whole coordination for you. So what I tell people is just, first of all, just try to start running new tests with WebDriver and keep your old Selenium RC ones. When they break because you change your application, probably just rewrite those. That's kind of a more realistic approach for people that is busy doing other stuff instead of just taking on a full-on 6-month project for rewriting everything. If you can do it, if you can afford it, it's awesome, but most people are really busy. So starting from zero, what we did at Sauce, at first, we only had Selenium RC before the merge happened. So we have a lot of Selenium RC tests. And basically, starting on several months ago, or a year ago at least, we just created a Selenium 2 test case, which creates a driver for us, and which is now new tests are all written using Selenium 2, and we have all tests in Selenium 1. And whenever we need to update them, or whenever we feel like it's worth it, we just rewrite some of the tests. It's a pretty easy to take approach. And the good thing, again, the grid handles both, RC handles both, so you don't have to worry about 2 separate infrastructures for Selenium 1 and Selenium 2. Just have one grid and hit it with whatever protocol you want, and it will just work, which is pretty rad. All right, seems like that's it. Thank you, guys.